Okay, we begin looking at this bit of notes about the chemical composition of soils. So, when you understand the type of chemicals that are within the soil type on an ecosystem, then it will help you to understand how that particular ecosystem, the soil that ecosystem has, how it is able to support the type of plant life. Because it's on the basis of the ability of that soil to support plant life that then that ecosystem can support eventually other forms of life. So therefore it means when we appreciate soil chemistry of a particular ecosystem, then we are able to know, for example, how that eventually impacts that ecosystem in general. Because if a particular ecosystem is able to support abundant plant life, diverse plant life, then it is equally able to attract different other types of life. They will have, for example, more animals, insects, microorganisms. So it is therefore the importance of understanding the chemical composition of that soil. Once we understand it, then we can come up with ways of either ensuring that we maintain it in a healthy state or we improve wherever it's needed. For example, if the soil is too acidic, then you can come up with means of ensuring that you reduce the acidity. If the soil has a very high alkaline level, then you can come up with ways of ensuring that you reduce the abundance of the alkalinity of that particular soil. So among the key components, the key chemicals that constitute the components of the soil, one is minerals. So minerals result from the weathering of rocks. When rock break down, they eventually now release these minerals. And these minerals which come from the weathering of rocks, they happen to be actually the primary source of most of the essential nutrients that soil will have. The minerals happen in two categories: primary minerals and secondary minerals. The primary minerals, these are found in sand and silt fractions. Okay? And these primary minerals will release elements like potassium, calcium, as the rock is slowly weathered or broken down, then it releases either potassium or calcium, which are now the primary minerals. For the secondary minerals, they form through chemical weathering and are often found in clay particles. So in terms of the nutrient contribution of these secondary minerals to the soil is that they hold nutrients like magnesium, iron, and aluminium. So by virtue of it, then they will hold these nutrients, then they will slowly release these nutrients as and when they are needed. The other component is the organic matter. Organic matter is formed by the decomposition of the material either from plants or animals. And this decomposition will enhance soil health and soil fertility. So through the decomposition, we then create what we call humus. Okay? There is a stable dark substance which forms as this organic matter is broken down. That now creates humus. Humus helps to improve soil structure. It also helps to improve the water retention of that particular soil. And it also helps to improve the nutrient holding capacity of the soil. as nutrient reservoirs, they release, the organic matter will now release nutrients like nitrogen, phosphorus, and sulfur. And all these are released through or during the decomposition process. Okay. The other thing is soil water. So the water that is found in the soil. So the nutrients and minerals which are found in the soil should be dissolved by something before they are now transported. Okay, so water in the soil is what helps to dissolve these nutrients. So once the water has dissolved the nutrients, then it can transport these nutrients to the plant roots. So it therefore means that the water in the soil, or this soil water, is a nutrient carrier. Okay, so it will hold dissolved ions and it will make them accessible to plants, because the plant cannot take up these minerals, these nutrients, unless they are dissolved. And what dissolves these nutrients is the water. So the level of water in the soil is therefore an important characteristic. Another function, important function that the soil water does is it acts as a medium for chemical processes. Okay, so the chemical reactions within the soil will happen better when there is a bit of water in that particular soil. Okay. The other component is the air in the soil. So the soil air. So there are spaces between the soil particles, and between these spaces, from one soil particle to the other, what you find there is air. Okay. So those spaces between the soil particles will contain air. And that air is important for the plants and the microbes to survive. Plants will have their roots deep in the soil. Microbes live in the soil. Both of them need air to survive. So this air that you find in the soil, oxygen is essential for the respiration, for the roots to undergo respiration, and for the microorganisms to continue carrying out their activities. Then carbon dioxide is released both by the plant roots and the microorganisms. So the plant roots are doing all manner of processes, activities, respiration. The microorganisms are also breaking down the organic matter in the soil. So as a byproduct of these two activities, carbon dioxide is released as a byproduct. Okay. So it means then within the soil spaces, we'll find air, which will most likely be either oxygen or carbon dioxide. So there has to be a balance between the amount of air in the soil and the amount of water. If there is too much water, then you clog the soil, so there will be not enough oxygen. Then if there is too much air, we'll not have enough water. So there has to be a balance between just enough water and just enough air. If there is enough water, too much water, mizizi itaoza. Then if there is not too much water, then the roots will dry. Okay? If we have not enough air, then the plant will suffocate. So there has to be a balance between the amount of water and the amount of air that soils will have. Let's now look at the essential soil nutrients. So plants get most of their supply from soil. So that's why you have roots anchoring, mizizi inaingia ndani ya udongo, for two purposes. One, to pick water and minerals in the soil, and two, to hold the plant in an erect position so that the leaves of that particular plant can now access sunlight. Okay. So the plants need a balanced diet of nutrients to grow. Okay. And soil is the primary source of these essential nutrients. And these essential nutrients within the soil can be divided into three main categories. So one is the macronutrients. The other category are the secondary nutrients. Then the last of the three categories are the micronutrients. So we begin with the macronutrients. Macronutrients are needed in large amounts. That's why they are macro. So they are needed in large amounts because they are the primary building blocks for plant growth and development. So plant grows and develops on the basis of the availability of these nutrients. So these macronutrients include things like nitrogen, which promote leafy green growth. Okay, so because of the green bit, the leafy bit, then it means nitrogen is vital in the production of chlorophyll. Then once chlorophyll is produced, then photosynthesis will happen. But in the event that the soil does not have enough nitrogen, then the leaves will begin to undergo what we call chlorosis. Hiyo ni kukua na rangi ya yellow. Okay. The second macronutrient is phosphorus. Phosphorus supports root growth. It supports flowering, and it also enhances energy transfer. So its main role is with cell division and the storage of energy. Okay, so if a plant is suffering from deficiency of phosphorus because of the type of soil that is growing on, then that plant will have a stunted growth. Okay, itakuwa hairefuki ifike ile kiwango ambayo inatakikana. The other example of the macronutrient is potassium. Potassium strengthens plants. It improves the ability of those plants to resist disease, and it also helps in the regulation of water balance. So it does so mainly by activating enzymes. It also helps in the uptake of water. And because it deals or influences water balance, then it enhances drought tolerance. So inamaanisha wakati ya kiangazi, ile kitu inaweza saidia mmea ni potassium. So when a plant is deficient in potassium, then it will have brown, scorched leaf edges. Okay. The second category are the secondary nutrients. So these are needed in moderate amounts. The macro ones are needed in large amounts, but the secondary ones are needed in just moderate, kiasi. So these nutrients are still essential, but they are needed in smaller quantities compared to the macronutrients. The examples of these secondary nutrients include, for example, calcium. What calcium does, it strengthens cell walls, and it also helps in root development. The other example of a secondary nutrient is magnesium. Magnesium is a central component of chlorophyll. When you look at the chlorophyll structure, it has magnesium in it. So because magnesium is part of the chlorophyll, then magnesium is therefore crucial for the process of photosynthesis. The other secondary nutrient is sulfur. Sulfur is important for the formation of proteins. And because enzymes are a protein in nature, then sulfur is also critical in the activity of enzymes. The third example, the third category, is now what we have as the micronutrients. With the micronutrients, these are needed in very small amounts or in trace amounts. So plants need them, but in very tiny amounts. But they are still vital for the proper growth. So hata kama inahitajika kwa kiasi kidogo, lakini bado zinahitajika ili mmea uweze kukua vizuri. So the examples of these micronutrients are iron, for example. So iron helps in the production of chlorophyll. We have zinc, which is essential for enzyme function. So zinc is more of a coenzyme. Okay? So it is essential for enzyme function. Then you have copper, which is important for reproductive growth and in the formation of lignin. Lignin ndio inasaidia for strengthening, okay, for strengthening of the stem, of the branches and other things. Then you have manganese, which aids in photosynthesis and in the assimilation of nitrogen. Then other examples are like boron, molybdenum, and chlorine. So we've seen the different categories of the nutrients. But now it is important that these nutrients have some aspect of mobility. And if they are not having enough mobility, then they are likely to cause symptoms. Because if the nutrients cannot move, then the plants cannot get them. And if the plants don't get these nutrients, then those plants will have the deficiency symptoms because they are not getting enough of the nutrients that they need. So let's look at nutrient mobility and some of the deficiency symptoms. So to begin with, we look at what nutrient mobility is. So nutrient mobility refers to how easily nutrients move through the soil and within plants. Remember, the nutrient has to be dissolved in water before it can move. Okay? So if the nutrient is present in the soil, but it has no water the soil doesn't have water to dissolve that nutrient, then the plant will not get it. But once the nutrient is dissolved in water, then it will move and get to the root of the plant. Then now the root will pick it and move the nutrient up. Remember the xylem and the phloem. Okay? So therefore, on that basis, you can have nutrients which are either mobile or immobile. And with this, it then affects how the deficiency symptoms appear in plants. So with the mobile nutrients, these nutrients are able to move easily through the soil and even within the plant. So it means the nutrient, once it is present in the soil, it moves easily. Then because it is able to move easily within the soil, then the plant can pick it. And even within the plant, that nutrient will also move easily. So it then means that because the nutrient is not just moving in the soil, but also in the plant, then its availability to the plant is higher. Sasa inamaanisha, if where it is not present in the plant is likely to be in older sections of the plant. So like an older leaf. Okay? Because plants will pull nutrients to support new growth first. So the plants will bring nutrients, but zitaenda kufanya ile matawi ama sehemu ambayo inakuwa mpya kwanza. Then whatever now comes in later will now go to the older sections of the plant. So with the mobile nutrients, they move easily through the soil and even within the plant. So then it means that the deficiency symptoms for these mobile nutrients within the plant will be very minimal, but they will be showing up in leaves that are older because the plant will be giving priority to the new growth. Okay? So the immobile ones, the immobile nutrients. So these nutrients don't move easily. So So it means zikiwa kwa udongo zinakaa hapo tu, they don't move. Then it means now they cannot even be taken up by the plants as easily as they should. So because of that, deficiency will show up in younger leaves first. Okay, so whatever is being taken from the soil now will not have the immobile nutrients. And as the plant takes these nutrients up, inaipeleka to the new growth. Okay, so it is possible that whatever is coming from the soil does not have the immobile nutrients. So the deficiency for the immobile nutrients will happen in the younger leaves, but the deficiency for the mobile nutrients will happen in the older leaves. Okay, I think you've understood that categorization, that distinction. So why is it important for us to bother about this nutrient mobility? Why does it matter? So when we understand nutrient mobility, then we are in a position to diagnose which problems that plants are likely to be undergoing. Okay. For example, when you see yellowing of lower leaves, it will suggest a nitrogen issue. But while yellowing of new growth points to an iron or calcium deficiency. So within the plant, ile yenye inakuwa chini, it is older. Yenye inakuwa juu, it is younger. So what if the yellowing is for the lower section? Then it means the older ones ndio hazipati. But if the yellowing is on the upper section, on the new growth points, then it means the immobile nutrients ndio hazikuji. So when you know which is mobile, which is immobile, then you can target which section of the plant is being affected, and then how now do you provide or do you ameliorate that deficiency. Another important factor with the soil is soil pH. So pH measures the extent of acidity and alkalinity. So how acidic or how alkalinic the soil is now what we refer to as the soil pH. And this soil pH influences the availability of nutrients and the microbial activity. The soil pH as well ranges from 0 to 14. So anything less than 7, if the pH records less than 7, it means that soil is acidic. If the pH is 7, it means the soil is neutral. If the pH is more than 7, then the soil is alkalinic. But why does the pH matter? So one is nutrient availability. There are some nutrients that are more available on the basis of what pH is present in that particular soil. So for example, nitrogen, phosphorus, and potassium, they are only available in neutral to slightly acidic soils. But when you go to more acidic soils, then the elements that are available, okay? So in more acidic soils, elements like aluminium and manganese can become toxic to plants. Then in alkaline soils, nutrients like potassium, nutrients like iron and phosphorus will become less available. So the extent of availability of these nutrients is a basis of the pH of the soil. Okay, so it means the pH of the soil affects which nutrients are available to the plant. The second thing that the pH affects is the microbial activity. So most of these beneficial microbes, we are talking, the beneficial ones are the ones like those that deal with the decomposition, those that deal with the nitrogen fixing. Those ones will thrive more in a neutral to slightly acidic soils. So if the pH is 7 or possibly to around 6, then these beneficial microorganisms can survive. But in very acidic or very alkalinic soils, then the microbial populations will decline. With a decline in the microbial populations, then the ability of the nutrients to be cycled and the organic matter to be broken down will reduce, because the organic matter is broken down by microorganisms. Nutrients are cycled. Remember the nitrogen cycle. Those are cycled by microorganisms. So if the soil does not support these microorganisms, then it means there will be no microorganisms to break down organic matter. There will equally be no microorganisms to help in the cycling of nutrients. Another impact of soil pH is soil structure. So soil pH affects or impacts structure of the soil. Okay. So when you have extreme pH levels, then you can lead to a breakdown of some soil aggregates. Okay. So extreme pH levels can then lead to a reduction in aeration and even a reduction in the ability of water to infiltrate. So either you have very acidic or very alkalinic. Then in that way, you will lead to a breakdown of those soil aggregates. So extreme pH will impact the level of aeration, will impact the ability of water to infiltrate, and will also impact the ability of plant roots to penetrate that particular soil. But now, how do you manage the pH? So possibly, you want to reduce acidity. When you are reducing acidity, then you are raising the pH. Because if it is 0, then it's very acidic. So you want to raise that pH. How do you do that? To raise the pH, it means you are reducing the acidity. So to reduce that, you just increase lime. Anything that is alkalinic, unaongeza kwa hiyo udongo. Okay? To lower the pH, it means you reduce the alkalinity. Because when the pH is high, if you have it as 12, 13, 14, that is highly alkalinic. So to lower it, kuipunguza itoke 14, ikuje 8, 7, 6, 5, you'll have lowered the pH, but you'll have reduced the alkalinity. So what do? You use any acidifying component. So you add, for example, fertilizers that can acidify. Fertilizers zenye zikidissolve kwa maji zina increase the level of acid in that particular soil. Okay. Another component is the cation exchange capacity. Another important component of the soil. So cation exchange capacity, otherwise abbreviated as CEC, is a measure of the ability of soil to hold and exchange positively charged nutrients. So anything positively charged, these ions, we call them cations. So that's why it is cation exchange capacity. So the capacity of that soil to hold and exchange these cations. Okay, so that is the cation exchange capacity. So if the soil, you think of the soil now like a nutrient holding room. So if the soil holds some particular nutrients, it is now it to determine which ones to supply and which ones to hold onto. Okay, so that determination of the positive ones, the ability to release, to hold on and release and keep exchanging, that is now the cation exchange capacity of that soil. So the key concepts in this, the cations are positively charged ions in the soil. Think of calcium ions, magnesium ions, potassium ions. Okay, those are positively charged ions. Then the exchange sites. These are tiny negatively charged particles in the soil. The ions are positive. then it means there have to be negative sites, negative ions within the soil, which will attract the positive ions so that they can now keep exchanging. So the exchange sites, these are tiny negatively charged particles. Okay. So these are the ones that will now attract. Remember the rule of the thumb. Positive attracts negative. Okay. So if these tiny negatively charged particles are present in the soil, then they are the ones that will be able to attract these positively charged ions within the soil. So the more exchange sites a soil has, the higher the soil's nutrient storage capacity. If the soil has more exchange sites, it just means it has more negatively charged particles. So those more negatively charged particles, the tiny particles in the soil, hizo ndio zitavuruta the positive ions, the cations now. So what are the factors that will influence the cation exchange capacity of any soil? The first is soil texture. So when you have, for example, clay soils, they'll have a higher cation exchange capacity. When you have sandy soils, they have a low cation exchange capacity. The other factor is the organic matter. So organic matter is rich in negative charges, and therefore it will help in boosting this cation exchange capacity. So by increasing the negatively charged particles in the soil, the organic matter will therefore help that soil to attract the cations, the positively charged ions. So more negative ions, more negative charges as a result of organic matter will therefore increase the many negative charges in the soil. Then those negative charges in the soil will not only attract, but they will also retain the cations. Okay. The soil pH. So pH will affect the availability of cations. Okay. So if the pH is high, then it will increase the cation exchange capacity. Okay. So a higher pH, a higher CEC. A lower pH, a lower CEC. So why is the cation exchange capacity important? The first thing is it impacts nutrient availability. So soils having high CEC will hold nutrients longer. Okay. So if the soil has a higher cation exchange capacity, such a soil will be able to hold nutrients longer. If the nutrients can be held longer in a soil, then there will be no need for frequent addition of fertilizers. But soils that have low CEC will lose nutrients quickly. Okay? So a lower CEC means that particular soil will easily lose nutrients. Okay? So it means then you have to keep adding fertilizer to that particular soil if you want to get a good production. Then CEC also affects soil fertility. So high CEC, as we indicated, we will be able to retain more nutrients. Low CEC, there will be fewer nutrients as a result. So how do you improve the cation exchange capacity? One, you add organic matter. Okay. Then two, you add or you use soil amendments. Okay. So what is it that you can add to the particular soil that you have so that you can amend its characteristic? Okay. Let's look at another aspect. How now nutrients are cycled within the soil and the function of microorganisms, the activities that microorganisms also play. Okay, so soil is in a way a living system because it has microorganisms in it. Okay? And these microorganisms are the ones that drive the cycling of nutrients. The process of nutrient cycling is essential for the growth of plants on that particular soil. Okay. So the processes, the nutrient cycling and the microbial activity will therefore ensure that nutrients are broken down. Once those nutrients are broken down, they are transformed. Okay. So the nutrients are broken down, then they are transformed. And after being transformed, they are now made available to the plants. Because before the nutrients are broken down, they cannot be transformed. And before transformation, to transform is to change from one form to another, to change the form. So before their form is changed, the plants cannot assimilate them. The plants cannot use them. Okay? So therefore it's important that these nutrients are broken down. Then after they are broken down, they are changed into a form that the plants can actually use. Then after they have been changed to that form, then they should now be made available to the plant. You can think of it like when you are cooking. Ukinunua sukuma, you have to ensure that you change that particular raw vegetable into something that is palatable. Ile kitu unaweza kula. But ukibadilisha na uache kwa sufuria, unless you serve it, unless you make it available, haiwezi ikafanya namna gani? Ikatumika. Okay? So that is the whole process. So the key processes in nutrient cycling. The first is decomposition. The first process is decomposition. So this process is where now the microorganisms, the microbes, in this case you are talking of things like fungi, the bacteria. In decomposition, they are now breaking down the plants that are dead, the animals that are dead. They are breaking down the organic matter to produce compounds that are simpler in nature. So breaking down is changing form to create a simpler form of whatever it is that was present for the microorganisms to work on. The second stage is mineralization. So in this stage, organic nutrients are now converted into inorganic forms that the plants can absorb. Okay? So you have things which are now present after being broken down into a simpler form. But even in that simpler form, the plant cannot absorb it. So what do you do now? You have to change it into a form which the plant can use. Okay? So you are sort of creating or changing it into a mineral so that it can be absorbed by the plant. Then the other stage, the other process, the third one is immobilization. So immobilization is sort of the temporary lockup of nutrients. Okay? So the microorganisms can immobilize, can make these nutrients not to be available. Okay? Ni kama mtu anataka kuchukua kitu na anapata umefunga. So you've locked it up. Whatever has been tied is now immobile. It cannot move. Okay? So while this immobilization can delay the availability of nutrients, but it also boosts the long-term soil health. Because if you make everything available at once, then itaisha yote mara moja. But what immobilization does ni kwamba it might not be available today, but it will be available tomorrow. So in the long term, the soil health has been boosted because of immobilization. The other component is now, the other process is nutrient fixation. So with the nutrient fixation, you have certain bacteria like the rhizobium which is present in the leguminous plants. Okay? These ones are now helping to convert atmospheric nitrogen into forms that plants can use. So it is changing nitrogen that is present in the atmosphere, bringing it into a form which the plant can use. If the nitrogen will just be present in the atmosphere, the plant cannot use it. But it has to be fixed. It has to be changed from what is in the atmosphere into a form that the plant can now use as a nutrient. The other process is denitrification. So with the denitrification, bacteria are now converting excess nitrates back into the nitrogen gas. So what is excess within the soil? It is now converted back into nitrogenous gas and released into the atmosphere. So in essence, denitrification and nutrient fixation are now acting in the opposite. One is converting it from an atmospheric nitrogen state into a form that the plant can use. That is nutrient fixation. But now denitrification is changing whatever is excess in the form of nitrates is converted back into a gas, then it's released into the atmosphere. So in essence, this helps to balance the nitrogen cycle. Because if we have these excess nitrates not being converted into nitrogen, then we will not have enough of the nitrogen gas when we need it. Okay? We will not have enough of it when it is needed. So what are the key players? What are the key components of this microbial activity? There are mainly three. One, the bacteria. These are largely the decomposers, which will now help in breaking down the organic matter. So whatever it is, you're thinking of things like the nitrogen fixers. All they do is they enrich the soil. So they are breaking down organic matter to get something that is simpler that the plant can use. The second player are the fungi. They help to decompose tough organic materials. We talked of lignin. Lignin inapatikana kwa cell. It makes in the cell wall. That's what makes the plant to be tough, to be straight. Okay? It's largely for protection. So it is a tough organic material. So that has to be decomposed, has to be broken down by fungi. Okay? Then the third player are the protozoa and nematodes. So what the protozoans and the nematodes do, they now feed on bacteria and fungi. Okay. So what they do now is they feed on them so that they can release nutrients back in the soil. So by feeding on them, then the protozoa and the nematodes now help in controlling the microbial population. Okay? And as they feed on them, they control the microbial population, but by extension, they are now stimulating the nutrient cycling because they are releasing these nutrients back in the soil. Microbial activity is actually the engine that drives soil health. And by driving soil health, then it will lead to plant productivity. Okay. So the many microorganisms that are living in the soil, they create a complex, interdependent ecosystem. And that system is now that ecosystem is now what actually sustains plant life. Okay? So by sustaining plant life, it will influence everything from the availability of nutrients to even the ability of that plant to resist disease. So microbial activity will influence many factors. One, nutrient availability. So microbes or microorganisms, they play critical roles in transforming nutrients into forms that the plants can actually absorb. So with examples of such are, for example, the nitrogen fixers. So you talk of bacteria like the rhizobia, which convert atmospheric nitrogen into a form which the plants can use. You have the phosphorus solubilization. So fungi and bacteria will release acids which help to dissolve phosphorus that is bound. So the phosphorus which was initially bound onto soil or other things is now made available for plants to take it up. That solubilization has been made possible because of the acid which the fungi and the bacteria released. Then this phosphorus is now made available to be soluble for the plant to take it up. Okay. The organic matter decomposition. Microorganisms break down organic matter, and as they break down, they now release nutrients into the soil. Another thing that microbial activity impacts on the soil is its structure and stability. So the byproducts of most microorganisms will help bind soil particles into aggregates. By doing so, it will help in improving the soil structure. So there are byproducts which microorganisms will produce. Some of those byproducts are the ones that will bind to the soil. By binding to the soil, it will now end up changing the structure of the soil. So you have, for example, the fungal hyphae. So the fungal hyphae will produce a sticky substance which will end up holding the soil particles together. Okay. The bacterial mucilage. This is a slimy substance which enhances formation of aggregates. Being slimy ni kama glue inashika hiyo udongo pamoja. Okay? So by extension then, the fungi and the bacteria is enhancing the ability of the soil to either be sticky, to kushikana pamoja ama hapana. Okay. Another component that microbial activity impacts is disease suppression. The microorganisms that are beneficial can at times outcompete the ones that are harmful. Okay? So by outcompeting, inamaanisha the beneficial ones zinatumia the available resources haraka. Then the harmful ones now die because they don't have resources. That's one way. But another way is that the beneficial microbes or microorganisms can inhibit the growth of harmful pathogens. By inhibiting, it means they make it difficult. They stop the growth of the harmful pathogens. So the examples here are, one, the antagonistic bacteria. So we have antagonistic bacteria which produce antibiotics that kill pathogenic microbes. That is a way of inhibition. The antibiotics which are produced by bacteria, they antagonize the growth of these pathogenic microbes. The pathogenic microbes, if they grew, they will cause disease. But their growth has been stopped through the production of antibiotics by antagonistic bacteria. You have the mycorrhizal fungi. So these fungi will produce some protective barriers around plant roots. Once these barriers are produced, they will block entry points for some of disease-causing microorganisms. Okay, so in a way, this fungi is protecting the plant from suffering from a certain disease. How did the fungi protect the plant? By forming a barrier around the plant root. Because had the barrier not been there, the disease-causing microorganism will have entered. Okay? The other impact is the organic matter breakdown and humus formation. I think with that one we've explained where we said microorganisms decompose organic materials by breaking them down into simpler compounds. The breakdown of the organic material now results in the formation of humus. Humus is nutrient rich. Okay, humus is nutrient rich, and now that is now what benefits the plant or what benefits the soil. The last bit is about bioremediation and detoxification. So there are certain microorganisms that can break down harmful chemicals and pollutants. So if the microorganism can break down something that is harmful, something that is a pollutant, then in a way that microorganism will have helped in cleaning that contaminant from the environment. That way, because you are using a living thing in the form of a microorganism to break down something that is harmful, something that is a pollutant, and by extension, therefore, you have cleaned that contaminant from the soil, then that one we call it as bioremediation. Okay. So microbes can also help in detoxification, the removal of toxic substances, or bioremediation, the use of a living thing to clean a contaminant in the environment. That is bioremediation. Okay. So with that, it now brings us to the end of this, where we were looking at the chemical composition of soil. We've seen all the way to the nutrient cycling and the microbial activity. So listen through the video. Should you have a question, I'm glad to respond. Either you can reach me through the email. My email is at the bottom of each of the pages of the notes. If not, I'm sure all of you by now, you have my phone number. Reach out, then I'll be glad to explain myself. Thank you very much, and I'm looking forward to our next interaction. Asanteni.